Electrical wiring in North America follows regulations and standards for installation of building wiring. Terminology: although much of the electrician's field terminology matches that of the electrical codes, usages can vary. Neutral wire is the return conductor of a circuit. In building wiring systems, the neutral wire is connected to earth-ground at least at one point. North American standards state that the neutral is neither switched nor fused except in very narrowly defined circumstances. The neutral is connected to the center tap of the power company transformer of a split-phase system, or the center of the Y connection of a polyphase power system. The United States electrical codes require that the neutral be connected to earth at the A-O service pane only and at no other point within the building wiring system. Formally, the neutral is called the A-OE grounded conductor A-Euro. As of the 2008 NEC, the terms A-O and neutral conductor A-Euro and A-O and neutral point A-Euro have been defined in the code to record what had been common usage. Hot is any conductor connected with an electrical system that has electric potential relative to electrical ground or neutral. Grounded is a conductor with continuity to earth. Leg is in A hot leg. A refers to one of multiple hot conductors in an electrical system. The most common residential and small commercial service in Canada and the US, single split phase, 240 V, features a neutral and two hot legs, 240 V to each other, and 120 V each to the neutral. The most common three-phase system will have three A-OE hot A-Euro legs, 208 V to each other and 120 V each to the neutral. An older, but still widely used high-leg delta system uses three phases with 240 volts phase-to-phase for motor loads, and 120 volts for lighting loads by use of a center tap transformer. Two of the phases are 120 volts to neutral. The third phase, the A-O leg A-Euro of the system, has 208 V to neutral and is not usually used for single-phase connections, so is distinctively colored. For larger commercial installations, 277 480ths V or 347 600ths V three-phase is common. An outlet is called a receptacle in the NEC. In the NEC, an outlet is a point in the wiring system at which current is taken to utilization equipment A-Euro. Electrical codes and standards. The National Electrical Code specifies acceptable wiring methods and materials for many states and municipalities in the U.S. It is sponsored by the National Fire Protection Association and has been periodically revised since 1897. Local jurisdictions usually adopt the NEC or another published code and then distribute documents describing how local codes vary from the published codes. Governments cannot distribute the NEC itself for copyright reasons, though parts that have been adopted into law are not subject to copyright. The purpose of the NEC is to protect persons and property from hazards arising from the use of electricity. The NEC is not any jurisdiction's electrical code per se. Rather, it is an influential work of standards that local legislators tend to use as a guide when enacting local electrical codes. The NFPA states that excerpts quoted from the National Electrical Code must have a disclaimer indicating that the excerpt is not the complete and authoritative position of the NFPA and that the original NEC document must be consulted as the definitive reference. New construction, additions or major modifications must follow the relevant code for that jurisdiction, which is not necessarily the latest version of the NEC. Regulations in each jurisdiction will indicate when a change to an existing installation is so great that it must then be rebuilt to comply with the current electrical code. Generally, existing installations are not required to be changed to meet new codes. Other code requirements vary by jurisdiction in the United States. In many areas, a homeowner, for example, can perform household wiring for a building which the owner occupies. This may even be complete wiring of a home. A few cities have more restrictive rules and require electrical installations to be done by licensed electricians. The work will be inspected by a designated authority at several stages before permission is obtained to energize the wiring from the local electric utility. The inspector may be an employee of the state or city, or an employee of an electrical supply utility. For electrical wiring in Canada, The Canadian Electrical Code is a very similar standard published in Canada by the Canadian Standards Association since 1927. Design and installation conventions. For residential wiring, some basic rules given in the NECR: phase wire in a circuit may be black, red, orange insulated wire, sometimes other colors, but never green, gray, or white. Specific exceptions apply, such as a cable running to a switch and back where the white wire will be the hot wire feeding that switch. Another is for a cable used to feed an outlet for 250 VAC 15 or 20 amp appliances that do not need a neutral, there the white is hot. The neutral wire is identified by gray or white insulated wire, perhaps using stripes or markings. With lamp cord wire, the ripped wire is the neutral, and the smooth wire is the hot. ANEC 2008 400.22, F, allows surface marking with ridged, grooves or white stripes on the surface of lamp cord. With transparent cord, the hot wire is copper-colored, and the neutral is silver-colored. Grounding wire of circuit may be bare or identified insulated wire of green or having green stripes. All metallic systems in a building are to be bonded to the building grounding system, such as water, natural gas, HVAC piping, and others. Larger wires are furnished only in black. These may be properly identified with suitable paint or tape. All wiring in a circuit except for the leads that are part of a device or fixture must be the same gauge. Different size wires may be used in the same raceway so long as they are all insulated for the maximum voltage of any of these circuits. The code gives rules for calculating circuit loading. Ground fault circuit interrupter protection is required on receptacles in wet locations. This includes all small appliance circuits in a kitchen, receptacles in a crawl space, basements, bathrooms and a receptacle for the laundry room, as well as outdoor circuits with an easy reach of the ground. However, they are not required for refrigerators because unattended disconnection could cause spoilage of food, nor for garbage disposals. Instead, for refrigerators and other semi-permanent appliances in basements and wet areas, a one-outlet non-GFCI dedicated receptacle is generally used. Two-wire outlets having no grounding conductor may be protected by an upstream GFCI and must be labeled no grounding. Most GFCI receptacles allow the connection and have GFCI protection for downstream connected receptacles. Receptacles protected in this manner should be labeled GFCI protected. Most circuits have the metallic components interconnected with a grounding wire connected to the third, round prong of a plug, and to metal boxes and appliance chassis. Furnaces, water heaters, heat pumps, central air conditioning units and stoves must be on dedicated circuits. The code provides rules for sizing electrical boxes for the number of wires and wiring devices in the box. In a fixture, the brass screw is hot, and the silver screw is neutral. The grounding screw is usually painted green. The foregoing is just a brief overview and must not be used as a substitute for the actual National Electrical Code. Comparison of U.S. practices with other countries. Electrical wiring practices developed in parallel in many countries in the late 19th and early 20th centuries. As a result, national and regional variations developed and remain in effect. Some of these are retained for technical reasons, since the safety of wiring systems depends not only on the wiring code but also on the technical standards for wiring devices, materials, and equipment. Grounding of distribution circuits is a notable difference in practice between wiring systems of the United States and those of other regions. Since the early 1960s, wiring in new construction has required a separate grounding conductor used to bond all normally non-current carrying parts of an electrical installation. Portable appliances with metal cases also have a bonding conductor in the flexible cable and plug connecting them to the distribution system. The circuit return conductor is also connected to ground at the service entrance panel only. No other connections from neutral to ground are allowed, unlike regulations in other parts of the world. Lighting and power receptacle circuits in North American systems are typically radial from a distribution panel containing circuit breakers to protect each branch circuit. The smallest branch circuit rating is 15 amperes, used for general-purpose receptacles and lighting. Often, 20 ampere circuits are used for general-purpose receptacles and lighting. In residential construction, branch circuits for higher ratings are usually dedicated to one appliance, for example, fixed cooking appliances, electric clothes dryers, and air conditioners. Lighting and general-purpose receptacles are at 120 volts AC, with larger devices fed by 3-wire single-phase circuits at 240 volts. In commercial construction, 3-phase circuits are used. Generally, receptacles are fed by 120V or 208V, and can include special current-rated outlets for industrial equipment. Lighting is usually fed by 277V. Equipment can be hardwired into the building using either 120 208V or 277 480V. Countries such as Mexico may adopt the NFPA standard as their national electrical code, with local amendments similar to those in United States jurisdictions. The Canadian Electrical Code, while developed independently from the NFPA code, is similar in scope and intent to the US NEC, with only minor variations in technical requirement details. Harmonization of the CEC and NEC codes is intended to facilitate free trade between the two countries. Wiring methods. Most circuits in the modern North American home and light commercial construction are wired with non-metallic sheathed cable designated type. This type of cable is the least expensive for a given size and is appropriate for dry indoor applications. The designation NM20Y indicates, respectively, the type of sheathing, the size of the main conductors, and the total number of circuit conductors. For example, NM14-2 cable contains 3 conductors at 14 gauge, a size typically used for circuits protected at 15 amperes. Circuits with larger currents will have larger conductors. Not all U.S. jurisdictions permit use of non-metallic sheathed cable. The NEC does not permit use of NM cable in large, fire-resistant, or high-rise structures. In Type NM cable, conductor insulation is color-coded for identification, typically one black, one white, and a bare grounding conductor. The National Electrical Code specifies that the black conductor represent the hot conductor, with significant voltage to earth ground. The white conductor represent the identified or neutral conductor, near ground potential. And the bare green conductor, the safety grounding conductor not normally used to carry circuit current. Wires may be recolored, so these rules are commonly accepted. In 240-volt applications not requiring a neutral conductor, the white wire may be used as the second hot conductor, but must be recolored with tape or by some other method. For wire-flexible equipment, connection cords have red as the fourth color. Unlike older European practices, color coding in flexible cords is the same as for fixed wiring. In commercial and industrial, unenclosed NM cable is often prohibited in certain areas or altogether. Therefore, it is almost never used by commercial electrical contractors. Most wiring is put in non-flexible conduit, usually IMT because of its cost and durability. Rigid may be required for certain areas, and additionally, vapor lock fittings may be required in areas where a fire or explosion hazard is present. PVC can be used where wire is run underground or where concrete will be poured. A duct bank is usually made of multiple PVC conduits encased in concrete. FMC or flex is used where IMT or other non-flexible conduit is impractical or for short runs, known as whips, to lights or other devices. For power circuits, the color coding uses the same colors as residential construction, and adds the additional wires used for 3-phase systems. Black, red and blue are used for hot wires, and white is used as the neutral wire in a 120 208V circuit. Brown, orange and yellow are used as hot wires, and gray is used as the neutral wire in a 277 480V. For grounding, regardless of the voltage, green is used. Several other types of wiring systems are used for building wiring in the United States. These include corrugated metal armored cable, mineral insulated cable, other types of power cable, and various types of electrical conduit. In industrial applications, cables may be laid in cable trays. Cable type TC is especially intended for use in tray systems. Special wiring rules apply to wet or corrosive locations, and to locations which present an explosion hazard. Wiring materials for use in the United States must generally be made and tested to product standards set by NEMA and underwriters' laboratories and must bear approval marks such as those set by UL. Approved wiring types can vary by jurisdiction. Not all wiring methods approved in the NEC are accepted in all areas of the United States. Wire types. Wire types for North American wiring practices are defined by standards issued by underwriters' laboratories, the Canadian Standards Association, the American Society for Testing and Materials, the National Electrical Manufacturers Association and the Insulated Cable Engineers Association. XHHW stands for XLPE High Heat Resistant Water Resistant. XHHW is a designation for a specific insulation material, temperature rating, and condition of use for electrical wire and cable. Wires with XHHW insulation are commonly used in the alternating current electrical distribution systems of commercial, institutional, and industrial buildings and installations, usually at voltage levels ranging from 110 to 600 volts. This type of insulation is used for both copper and aluminum conductors which are either solid or stranded, depending on size. According to Underwriters Laboratories Standard 44, XHHW insulation is suitable for use in dry locations up to 90 degrees Celsius, or wet locations up to 75 degrees Celsius. XHHW2 insulation, which is similar to XHHW, is suitable for use in dry or wet locations up to 90 degrees Celsius. THWN stands for thermoplastic heat and water resistant nylon coated. THWN is a designation for a specific insulation material, temperature rating, and condition of use for electrical wire and cable. Wires with THWN insulation are commonly used in the alternating current electrical distribution systems of buildings of all types and sizes throughout North America, usually at voltage levels ranging from 110 to 600 volts. This type of insulation is used for both copper and aluminum conductors which are either solid or stranded, depending on size. THHN stands for thermoplastic high heat resistant nylon coated. THHN is a designation for a specific insulation material, temperature rating, and condition of use for electrical wire and cable. Wire with THHN insulation is commonly used in the alternating current electrical distribution systems of all types and sizes throughout North America, usually at voltage levels ranging from 110 to 600 volts. This type of insulation is used for both copper and aluminum conductors which are either solid or stranded, depending on size. Many wires are rated both THWN and THHN, and are suitable for use in dry locations up to 90 degrees Celsius, or wet locations up to 75 degrees Celsius. See also, American wire gauge, twist-on wire connector. References. External links, the NEC at nfpa.org, Summary of NEC Color Code.